Hello everyone, this is MH Mubashir again. This is tutorial number 11 of BTC509 and this is the final tutorial before meet. Okay, this tutorial is all about the protein structure validation, and to understand the validation tools you need to understand a bit of theory. So here you can see that this is our amino acid 1 and this is amino acid 2. This is C terminal of the amino acid because we have carboxyl group here, and this is N terminal because we have amino group here. And these amino acid and these amino acid will make a bond which is known as peptide bond. So basically you can see that this peptide bond is formed between carboxyl groups C and then amino groups N. That is the bond between C and N. Remember that, this is very important. So we have a peptide bond here that is formed between C and N. And this carbon is known as alpha carbon. Same time this carbon is known as alpha carbon, and this is R group and this is R group as well. So we have two amino acids here. They are making a dipeptide. This is peptide bond formed between one carbon and one nitrogen. We all know that this nitrogen has a lone pair of electron, and because of that this lone pair of electron will try to make another bond with this carbon. So it will behave like a double bond. Whenever we are having single bond, it can rotate freely, but whenever we are having double bond, it can't rotate freely. So that means this area or this particular region can't rotate freely. So comes to this figure. Well, like I said to you that we have peptide bond here. That means it will act as a double bond character. And as it is acting a double bond character, it can't rotate freely. That means if it wants to rotate, it has to rotate throughout the entire region. That means like a plate. So whenever it will be rotating, it will rotate the entire region or the entire plate region. So this is an area, okay? And this is definitely our carbon. And similarly, this is another area. And two sides of alpha carbon, we have two plates. And we have an angle here. Here we have an angle and here we have an angle, okay? Angle between this carbon and this plate. An angle between this carbon and this entire plate. So this rotation, that means the rotation of this plate is known as psi angle, and rotation of this plate is known as phi angle. The plate which contains carbon with carbon alpha, it is considered as psi angle, and the plate which is at the nitrogen side besides carbon alpha, it is known as phi angle, and this is known as torsion angle or dihedral angle as well. Okay, so now let's move to the Ramachandran plot. So this is the basic of Ramachandran plot. Okay, so in the Ramachandran plot we are calculating phi angle and we are calculating psi angle as well. Okay, so if the value for psi angle is like plus 120 and if the value for phi angle is minus 100, then it will form beta sheet or beta strand. Okay, so all of the amino acids in a protein which will form beta strand will have an angle like this. Similarly, we can have left-handed helix, which is very rare, if the phi angle is plus 60 and the psi angle is plus 60. We don't have any structure within this area. If we see any amino acid within this area, that means it is not forming any beta strand, neither it is form anything related to the alpha helix. Rather, it will form some coil-like structure. Okay, so for the right-handed alpha helix, the phi angle is around minus 80 and the psi angle is around minus 60. So let's see an example of this. To check the protein structure quality, I'll be using one single server where we can get all the results of ERAT, Verify 3D and Ramachandran plot. Okay, to do so, let's search first ProCheck. If you Google ProCheck, then you can have a result like this: servicen.mbi.ucla. Remember, this is a page developed by UCLA. So let's click it here. After 10 seconds, it will take you to the real server. After going to that server, you have to upload the PDB file of your structure and then run programs. So basically we will be running ERAT, Verify 3D, and project. So if the value for ERAT is above 50, that means its quality is good. I mean, satisfactory, you can say. And also if the value for Verify 3D is above 80, that means it passed. Now we are waiting for the results of project where we can get the Ramachandran plot. Okay. ERAT basically calculates the non-bonded interaction among the atoms. Verify 3D assesses the compatibility of the structure with its amino acids. Let's click results. So this is the summary where we can get the result for Ramachandran plot, and this result is important for you. Okay. So here we can see that in the core region we have 58.3%, in the allowed region is 36.1%, and in disallowed region is 1.6%. We can have the figure for this one. Okay. So I'm clicking it here, Ramachandran plot. So after clicking here, this is the real Ramachandran plot figure. I was talking about the Ramachandran plot earlier, and we have seen that this is the phi angle and this is the psi angle. Well, and we also know that here we have the beta structures or beta sheet-like structures. Okay. So these red regions are the core region. That means this server is expecting all of your beta sheets within this angle and within this region. So this is the core region, and this is allowed region. That means if our amino acids are here, it is allowed, but the desired area is this one, and this area is generously allowed region. Okay, this area, all the dots here represents the amino acids. So in the most favored region we have around 300 amino acids, which is 58.3%. In the additional allowed regions we have 186 amino acids, which is 36.1%. In the generously allowed region, we have amino acid of like 21, which is 4.1%, and in disallowed regions, like in this region, this area, and this area, we have amino acids of 8, which is 1.6%. So in total 100%. So here, in the most favored region is 58.3%, but if your model quality is good, then we would get 90% in the most favored region. Okay, that means we will get a very good and very nice Ramachandran plot where you will get all the dots within this, or most of the dots within this red area, or all the dots within this red area and yellow area. So I believe you have got a very clear idea about the protein model validation. Now still, if you have any question, please join the live session on the next Sunday, and this live session is the last live session before the mid, and I'll be answering all your questions in that live session. Till then, stay safe, stay healthy. Thank you.